Perl memory use. I hope that says thank you. I'm honoured to be speaking to you today. I was delighted to be invited and delighted to come. It's my first time coming to Japan, and it's been a real pleasure, so thank you very much. Now, I don't speak any Japanese, except perhaps arigato? That's my one Japanese. So I've had to call on Google to provide some translations for my headings, but they might not all quite be appropriate.
It says you are a table?
Yes. So this is a joke that Jesse told me about somebody who learns one phrase when they go to a foreign country. Don't shoot, I am a table. And it conveys a very useful message, and you can ask Jesse for the story. So what I want to do today is explain a bit about process memory, identify some issues, and explain why it's been so hard to get a clear picture of what's happening in the memory of a Perl process. Show some useful tools along the way, and then demonstrate some new software. I'm also delighted, having been invited and come all this way, that I have something new to show you that I think you're going to find useful. Who has experienced this? Yeah? Or perhaps this, the Linux out-of-memory killer? Or perhaps this? But more often things just run slow and take far too long. So let's take a look at how the memory of a process is constructed. It's made up of segments, and these segments have various purposes. There's the C code, the code of Perl itself. There's read-only data and read-write data, and then there's the heap that we'll be talking about later, shared library code, and the C stack. Now, to get some insight into the memory use, you can use tools like this. On Linux, you can cat this /proc, and then your PID, and then that stat file. But you get back a bunch of numbers. That's not very friendly. There's this slightly more friendly version, but that's still not very nice. And then there's PS, you know, perhaps slightly more portable, but does anyone know what units those numbers are in? And then there's top. Top is a good standby and sheds a bit more useful light and gives you some sense of the units too. And then also on Linux, there's this status, which gives you a very detailed insight. The output is several pages long, but I've just shown a fragment here that gives the key values: the total process size, the size that's currently resident, and the amount of data, the heap that we'll be talking about later. Now, you can also cat this file called maps, and the maps will give you one line for each of those segments that I mentioned earlier. Now, the one we're going to be most interested in is the heap, but you can see the C library and the Perl library and the stack and everything else in there. And there's another file called smaps that gives you even more detail for every single one of those segments. It gives you a whole chunk of detail. So here I've highlighted the one for the Perl library. And you can see the size of the Perl library executable segment and how much of it is currently resident, the resident size of that segment. So to explain about what's resident and what's not resident, I need to talk about memory pages. So from the process's point of view, memory is just one large contiguous span of address space that it can use however it likes. From the system's point of view, it's divided into a lot of pages. And under the covers, the system is mapping the process pages into physical memory however it likes, and it can change that whenever it likes, and the process doesn't know that it's happening. So there's our segments again, and you see I've kind of just coloured some randomly to show that although the process thinks it has that memory, the operating system may not have that chunk of memory, that page of memory, in physical RAM. So the key point I want to get across is don't use the resident set size to measure the memory of your process, because the resident set size can go down even while the size of your process is going up. Okay, the heap. So this is the interesting bit from Perl's perspective and from your perspective. This is where all your Perl stuff goes. This is where the your Perl program goes and your Perl data goes. So we're going to talk a bit about your data, and you don't need to understand these diagrams. They're diagrams showing you the structure of the data inside the Perl interpreter. And it'll become clearer as to why I'm showing you the diagrams a little later on. The point I want to get across is two things. Firstly, the data is broken up into lots of tiny little bits with pointers between them. And secondly, this terminology at the bottom of heads, bodies, and data. Those are the three things that most of the data is made up from. Now, so on that page you see an integer, a string, and then a number that also contains a string version. Here you have an array and a hash. You can see the hash is starting to get pretty complicated. There's pointers to lists of pointers to whatever. And then it gets even more complicated when you get into symbol tables, which are kind of specialized form of hashes. Again, you don't have to memorize all this stuff. I just want you to have a sense that the memory is made up of lots of little bits with pointers between them. Now, one way you can gain an insight into that structure is through the devel peek module. And you can give it a reference to something, and it will dump out a textual version of the values and the relationships. So here you can see a reference to a hash, and you can see the three levels of output. You can see the reference is the first indented level, and then the hash is the second, and the hash element is the third. And that's grand, and that's useful, but it doesn't. You can't really see very deeply into a structure, and even if you could, it would be too much output. Now, devel size gives you a way of measuring the total size of what is owned by a reference. So if you've got some big data structure, you can ask devel size, how big is this? And it'll chase all those pointers, totaling up all the memory used and giving you the sum total. And that's grand, and it works very well, and it's fast. There are a bunch of bugs and limitations, which I will be fixing, hopefully, in the near future. But the point is, this is the tool that knows how to chase all those pointers. So, memory profiling. What is memory profiling? I mean, ever since I did the MIT Prof, a lot of people said, hey, wouldn't it be great if MIT Prof could do memory profiling? And I kind of scratched my head and thought, well, it makes some sense. Instead of measuring CPU time from statement to statement, from subroutine to subroutine, you can measure the memory. Has the memory grown here and dropped here? So Nicholas Clark developed an experimental version of MIT Prof that did just that. But it turned out to not be very useful. It wasn't easy to extract meaning from the data. Because sure, the memory use goes up in one place and it goes down somewhere else. But what you really care about is not those two places. You want to know what's holding the data in between. And especially if you have a leak, of course, then the memory never goes down. So, one of the problems in understanding Perl memory is that Perl is very liberal in its use of memory. One of the ways in which Perl is so fast is because it avoids freeing memory if it thinks there's any chance it's going to be using it again. And this leads to some surprises. So, for example, here we have a subroutine with a lexical variable that has grown to about 10 megabytes. And you call the subroutine once, and your memory use has gone up by 20 megabytes, even when the subroutine has returned. Does anyone know why? So this comes as a surprise to a lot of people. It didn't come to a surprise for me that it would go up by 10 meg. It was a surprise to me it went up by 20. And it was only just recently that I could kind of see why, and I'll show you the tool that let me see why shortly. Now this problem, it gets worse if the subroutine recurses. So here is the same code, but now it'll recurse. And if it recurses 50 times, you'll end up with a gigabyte of memory that's just disappeared. And you'll never get it back. That'll never be freed. So this comes as an even bigger surprise to people who go, oh no, if I'm throwing big strings around and I have recursive functions, that's a lot of memory. Now what Perl is doing for you is it's saving those buffers. So the next time you call the subroutine, the buffer is already there, ready to be used, and that's great. But what happens if you're never going to call the subroutine again? And that's Currently, there's no way of tuning that, and there's been talk occasionally of having a use less pragma. So you could say use less memory, and it would turn off this kind of behaviour. So I came up with a plan. And I came up with a plan shortly before OSCON. I've been kind of cooking this idea, and I didn't have time at OSCON to actually do very much. I get a new microphone. Thank you.
Better grab that one.
Yay. So I didn't get a chance to do very much. So my talk at OSCON was really about my plan. And now, thankfully, I can describe the plan and show you the results. So I think devel size is the thing that knows how to chase all these pointers. And that's an important bit of knowledge, and it's complex knowledge, and it's very version sensitive in Perl versions. So what I wanted to do was add a way of kind of adding a callback so that some other bit of software could plug in and kind of hitch a lift as devel size chases these pointers. Then I also needed to add a way of having a sense of where you are in that chain of pointers. So some sort of way of naming the chain of pointers that have been followed. And also, devel size only gives you a way of saying how big is this structure. I wanted a way to say how big is the whole of Perl. I want you to chase every pointer that you possibly know about and give me information about the whole lot. And then I want to stream all that data to disk, and then I want to write some tools to visualize it, to actually see everything. Then kind of the next step would be to break that up a bit, because one of the problems with this is that if you've got a bit of memory that has multiple pointers to it, it'll be named according to whichever pointer got chased first. So it would be nice to be able to kind of separate the scan so you chase the things that have names, and wherever you end up with something with multiple references, you kind of queue that for later. That's a subtlety. And then at the end, it should be possible to take a snapshot of memory at one point, a snapshot of memory a bit later, and then compare the two. And that gives you the time dimension. Okay, so you might run it typically just at the end of the program. You know, where is the memory being used? But also, if the snapshot's kind of reasonably fast, you could take it at multiple points. You can take multiple snapshots and compare them and see how the memory ownership has changed. So I'm happy to say that I've got that much done so far. And I haven't released it yet, and Adam is twisting my arm to get it into a public repo very soon. I don't have a name for it yet. It's currently sort of a hacked version of devel size, but I'm thinking you call it devel size me graph. What do you think? Again, that's an Adam name. So I'm ready to demonstrate it. So, live demo. What could possibly go wrong? Okay. Okay, so to enable this functionality in devel size, you set this environment variable. This is all sort of hackish stuff at the moment, but there's basically that environment variable would give it the file name to write the raw data to. And if you give it a pipe, you can pipe it straight into a program. So here, just to make it easy, I'm piping it straight into my program to analyze the tree. And I'm asking the analysis software just to write out a textual version.
Can you make these fonts a little bit?
Bigger font. I love bigger fonts. Look, I'm putting on glasses. Maybe I don't need to put on glasses and I'll just put a bigger font. That would make a lot more sense. Is that better?
Yeah.
A bit more? Okay. So, let's find... Okay. Let's do a nice simple one. So there, that's the size of an integer. It's saying I have an integer scalar and it has a 24-byte SV head. That's a scalar with a string with a 24-byte head, a 16-byte body, and a 16-byte length. Now, what am I going to do? Oh, yeah. Okay. I did a whole bunch of these before I came out. Where is the one I want to do? Aha, there we go. So this is a number that's also been used as a string. So you can see there, if I don't use it as a string, that it just has the head and body, it's an NV, but if I use it as a string, it gets turned into a PNV with a string version. So you can see the level of detail it's absolutely everything, right down to the detailed structures. Now, so hopefully now these diagrams make more sense to you. So I've just shown you those versions, the integer, the string, and the number with a string. Oops. There! There! Okay. I've lost my sense of where I am. There I am. Okay. So now let's do an array. So there's an array with 3 elements. Each element is an integer. Let's do a hash. And there's a hash, and you see the HV max is the array of hash elements, and there's an element, and there's the element key, and da 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 da. You remember the hash diagram was very messy? Well, that's all the messy bits that go inside a hash. So now let's do something a bit more interesting and take a look at a sub. Whoa, we're scrolling off the screen already, so let's do that again. So here's a sub. So you have the CV, and you have a name, and the GV, and the GV heck, and the file heck, and the pad list, and the outside, and the ops, and the file GV, and then a bunch of scalars referenced by the ops. You know, this is intense detail. So now let's do something. Let's look back at our problem. This bit of code here. So this bit of code is the recursion. So there's the output of the recursion. You see down the bottom, that's the 22 meg that it's using. But there's a lot of stuff here. How are you going to find the numbers? Okay, so let's try asking our software to write a dot file. If you're familiar with GraphViz, you'll see what happens. But before I demonstrate that, let's go back to doing a string. There's our string. There's our string. Let's go back to doing a string with a number. There's a string with a number. There's a hash. And then, well, let's just do our sub now, shall we? Cut the stress. Okay, there's our sub. Bam. Okay, and up here, thank you. Up here, you see you've got the 21 megabytes. And if you look along these children, you see that all of that's coming from the pad list. And if you look at the pad list, you'll see here, yep, 21 meg here. And I've got 10 meg sitting in this my variable, and 10 meg sitting in this temporary pad variable. And that temporary pad variable is the temporary space, the temporary value that got assigned to my lexical variable. Okay? So now you can see everything. Now that's good, and that's great, and worthy of a new. Thank you very much. But it's not enough, because when I say I want to see everything, I mean I want to see everything. So let's just see what happens if I do a stash, just for the sake of being tricky. Right, what we get up here is rather large. You know? And at this point, you start losing the will to live. How are you going to make sense of that? You know, you spend forever chasing that down. So what we do is we ask our actually I'll just do should be yeah, and then node.db. We ask our software to write, instead of writing a dot file to then produce a graph from, we'll get it to write a SQL-like database containing all the data. And then, when we do the size of that, we can nip over here and get a tree map. And the tree map, let's bring that down slightly, the tree map allows us to drill down into the data. Oh, I keep double clicking. Ooh. So now let's go back to this example with the recursive pad. Let's even, well actually I'll just leave it like that. Refresh this. So here you can see that's the function name, and here's the pad list, and there's the pad variable. And here it's showing you straight away, it's taking you straight to the lexical variable and the temporary variable that are holding 10 megabytes each. Okay, and you can see it because the bigger the box, the more the memory. So it makes it very easy to drill down straight to where the big memory hogs are. Okay, so now that's great and that's very useful, but still I want the whole thing. I want to know the size of everything. So I have this function. Perl size. I'll just do it this way. Da. Perl size. Can't spell. Now here, you see something interesting. Well, so right up the top here, this is the Perl size, so it's 8.7 megabytes. The only thing loaded is the Devel size software. There's nothing else in there. And you see the biggest memory space? There's 8 megabytes sitting in the malloc area as freed. So that's memory that Perl has asked for and then given back to malloc. But malloc can't do anything with it. It's almost impossible for malloc to release the memory back to the operating system. So it's sitting in malloc. Now this is something that hasn't been easy to see before. So let's try that again, but this time, just for fun, we'll load in Goose. I should have turned off that tree output. Okay. So here's Moose, and you see still there's now 4.7 megabytes of memory sitting in malloc that's been allocated and freed and not used. So there might be something that Perl can do to kind of use less of that. And over here we have main extends. Now, I suspect the reason that main extends shows up so much is this pointer chasing problem. That extends was the first point through which the pointer chasing then went off and grabbed all sorts of stuff. So until I work on the Devel size logic to make it sort of a multiple phase scan, I think there's more in there than we can really blame Moose for, or extends. So you see down here, actually let's just, so that's the namespace. Whoops, I keep double tapping, but I only need to tap once. So that's the namespace, that's the main. But if you go back here, over on this side you have the freed malloc, and down here we have a bunch of others. Why isn't that going? It's dying. Right, I don't know what's happening there.
You use too much memory.
Could be. Could be. Quite possible. Time for questions, I think. So does anyone have a question? And we'll see if that sorts itself out. Otherwise I'll kill it off and restart.
So why 20 megas and not why 20 megas, not megabyte, and not
10?
Well, and not 10.
Well, because we created a.
そうなんですよ。
Yep.
で、結局なんで20メガバイトだったのっていうのを説明を聞いてます。
Okay, so we assigned a 10 megabyte string to the lexical variable, but that 10 megabyte string had to exist somewhere before it was assigned to the variable, and that the expression that created the 10 megabyte string before it was assigned is also an anonymous lexical variable, and that's holding the original copy of the 10 megabyte string.
And you notice that you have it at compile time because of constant folding.
Oh, you have it at compile time?
Yes.
You have the 10 meg gets created at compile time actually.
Because of constant folding.
due to constant folding. So it's trying to hang on. Constant folding is an optimization. In this case, it's pessimization.
Okay. I mean, usually it's a very good thing.
Yeah.
Yeah. But I think people, obviously most people don't sling about 10 megabyte strings, but some people do, and they don't know what the effect is. And now we can actually see the effect, the consequences.
で結局何かというと、その10メガバイトの文字列を1個作って、それをアサインする変数があるわけですけど、作ったその7種のメモリ領域があって、それをアサインする領域があるので、その両方とも存在しなければいけないから、10メガ10メガで20メガバイトになる。で、ただし7種の方はコンスタントフォーリング定数を最適化する仕組みが働くので、それが先にコンパイル時に作られて、それがずっと残るという形になります。
Okay, so well, no, but I know what's happening. If you look down here, do you see this space? So there's I don't know what the technical term in Japan is, but there's a bazillion scalars, and they're in this thing called unaccounted unseen, which is a bucket. After devel size scans everything that it thinks it can reach, it then scans the arenas that hold the heads of everything to look for anything that it missed in the official scan. And at the moment, because I'm still hacking on it, it still misses lots of things. So that bucket contains everything else. And obviously with Moose loaded, there's a lot of everything else. So when I clicked on it to expand the tree map, it kind of got a bit mad. So that was a refresh. So this time I won't click on that one. I'll try clicking on this one and cross my fingers. But this will probably also die. Because by default it loads in 3 levels of the tree map. So when I go 1 level further in that direction, it's going to suck in all that extra data.
Shall we take another question?
We could take another question.
じゃあもう一個質問を待ってる間に。質問、今ですよ、聞くなら。
Okay. What's the software you're running inside your web browser there?
まあこれはなんでソフトウェアなんだっていう話です。
Okay, the tree map software is called the JIT, or just JIT, the JavaScript Information Visualization. The website is thejit.org.
Okay.
It's the same tree map software I used for NYTPOF. And I wrote NYTPOF several years ago now, and I looked around for tree maps. And again, this seemed to be the best one because it allows you to do dynamic loading, to load nodes on demand, which is very important in this case because if you have a bazillion nodes, there's no way you can load them all in, as we've just seen.
Okay, cool, thanks.
これはザジっていうソフトウェアで、なんか NYT プロジェクトを使ってるらしいです。でこれは一番自分で見たところは一番良さそうな、動的に内容を、ロードできるやつなので、一番いいんじゃないかということで使っています。
Okay, so and what I'd like to be able to do in future is to be able to have this tree map of a dump, but also to be able to compare 2 dumps and have the tree map coloured according to whether a particular part of the tree has got bigger or smaller. Oh, here it goes. You should see that kind of zoom up and expand, and then my laptop burst into flames. So it should be possible, so you could colour kind of green for parts of the tree that have got smaller and red for parts of the tree, and use colour coding to show. So you could take a snapshot just before you call a function, take another snapshot just after. Now obviously if it's a big process, this processing could take a while, but you'll know you're going to get everything. You're going to see the whole picture, however complicated that might be, eventually. Okay. Right, that could be quite spectacular when it goes, but we might have to wait a week for it to get there.
Another question?
Another question?
ということでまた待つんで、まだ質問があれば。その辺のなんかパールのメモリ内部を知ってそうな人たちからすごいツッコミはないんですか？
日本語ですか？
どうぞ。
これどのぐらいプロセスの中のどれぐらいのメモリの使用表を説明できるのか ちょっと知りたいです。
どういう意味？
つまりファイルが、エクセスモジュールとか使ってるとファイル管理してないものに。
So who wants to know what the extent to? Oh.
Hey! Got there eventually.
So that's the question. He wants to know what the extent of to what extent this can chase the used memory. For example, if you're using the access modules, it's going to use memory that Perl never knows about, and if it handles that or not.
Okay. Great question. So that's why I wanted to pop up this page.
その説明はこれだそうです。
So over here, this is kind of the others. This is other stuff. And one of the items in here, hopefully, that you possibly can't see. Thank you. Yeah, it's too small to see, but you saw it on the other examples. There's a section that is memory freed. So I've asked malloc, how much memory are you holding on to that has been freed? What I want to do is extend that idea of asking the operating system, how big is the heap? And I know that I'm trying to find everything that adds up to that much space. So if I've asked the operating system how big the heap is, and I've accounted for everything that I know that Perl has, anything else would be from extensions. Okay, so that's the way I'm hoping to do it. So the outer box that currently says Perl, eventually I'll change that to say process, or just heap. And the Perl will become a box within that. And then there'll be another box saying stuff I don't know. You know, things I haven't been able to identify. Kind of the difference in my accounting between everything that I've added up and what the operating system says my heap size is. And kind of my job is to get this software good enough to make that as small as possible.
だからまだできてないんですけど、オペレーティングシステムの方に、このヒープにどれだけメモリーが蓄えられてるかを見て、そこから自分がパールが持ってる分を引いて、それでパールから見えるところを引いて、その差分が、エクステンションとか使ってメモリーなので、そこから割り出すということをやりたいと。これはもうちょっとしたらできるはず。でそのうちその一番さっきの外側のグラフの外側はパールになったけれども、それをプロセスだとかヒープだとかにして、その中にパールがあってでの差分があるっていう形で表現したいということです。はい。You want to go on? You still have more?
No,
you don't.
I'm done. I can take MIT Prof or DBI questions if anyone has one.
なんか一応話は大体これで終わりらしいんですけど、もしこれの話じゃなくて、あと NYT プロフとか、そういうティンバースさんが書いたようなモジュールの質問とかもあったら受け付けるそうですが。NYT プロフ使ったことない人？ある。質問あるでしょ？さっき誰か。
すみません、日本語で。
はい。
こっちの今作っておられる方の話で、もう言われたかもしれないんですけど、これって動いてるプロセスの今の状態をリアルタイムにすることが知ることもできるのか、それとも一旦そのプロセスが最後まで走り切っている状態じゃないと
それは多分スナップショットだと思いますけど、一応聞きます。So this takes snapshots of memory usage, right? It's not like a real-time graph usage, right? いや、スナップショットを時々取るわけです。だから動いてる時にここでスナップショットを取る、こうスナップショットを取るっていう形でやる。
一応そのウェブフレームワーク自作しているとして、それの今なんかこうどんどん膨らんでいってるけれども、それだからどうなってるのか調べるっていうのは、その時々のスナップショットを今どうなってるのかというのを見ることはできると。
So if you were trying to profile on a web application, whatever that's growing in size, you have to take snapshots with, let's say, like each request or not, and then compare that, right? そのウェブアプリケーションの場合はやっぱり1リクエストとか定期的に取って、それを比べていくことによって何が起きているのかを見るという形になります。
ありがとうございます。
So I'll just add that the software that takes the snapshot is actually surprisingly fast, and it uses no memory allocation. It's all done on the heap. It's very CPU efficient. The bottleneck is just streaming the data out, and I intend to add gzip compression, the same that MIT Prof uses. So the bottleneck of streaming the data out will become smaller when it's compressed. So I think it should be efficient to take snapshots even of large processes with many objects.
そのスナップショットを取るプログラム関数というのが、比較的効率がいいので、というか思っているよりはるかに効率がいいので、どちらかというとボトルネックはそのストリームとしてデータを出すところの方がボトルネックになる。なので今後 NYT プロフで今までやったような gzip による、圧縮をかけて、ストリームを出すということもやる予定です。なので結構大きなプロセスであってもできるはずだと。はい、他に質問があれば。みんな NIT プロフ使ってるでしょ ?DBI 使ってる人は
Are you walking just the SVs in the Perl interpreter, or do you also walk through all the octaves?
分かんない人は分かんないと思うけど、パールの中の SV だけを見てるのか、それともオプトリーも見てるのかっていう質問です。
I'm walking the octaves as well. That might take a while. So, oh, there we go. So if I buzz down here, let's pick a smaller one. So this is just some function I picked at random. I don't know why that's slow.
答えから先に言うと、オプトリーもちゃんとスキャンしてるそうです。
So yeah, it calls all the ops because there's a lot of SVs attached to the ops that have references, so it should handle closures. Oh, that reminds me. So after it's scanned everything that it can find normally, it does a sweep of the arenas, looking for anything that it hasn't found previously. And this is how it'll be able to find leaks. If you have leaks, the leaks won't be accessible from the main tree as it calls the tree, but it'll find them when it checks the arenas. So you should be able to plot those kind of graphs and have tree maps of your leaks. And by being able to see the references of the leaks, oh, that's a big one, that was a bad choice. By seeing what the leak structures look like, you should be able to recognize where they come from.
オプツリーは、そのオプツリーの先にさらに SV がついてたりするので、基本的にオプツリーもパースしないと、メモリーの使ってる量は分からない。で、あとさらに言えば、オプツリーとかをパースした後、もう一回パースしていて、アリーナに残っているまだタッチされてないメモリー領域も見てます。で、これを見ることによって、リークがあるかどうかを発見できます。はい、じゃあ次、はい、じゃあ他に。
初歩的で申し訳ないんですけど、先ほどシェルでセットしていたメムサイズ環境変数ですかね、は何で使われているものなんですか。
それは多分僕答えるけど、あれは今作ってるレベルサイズになんとかの特殊な関係性だと思います。The environment variable that you're setting for, that's your custom environment variable.
Oh yeah, that'll all change. That's just me hacking to create something that I can demonstrate. I haven't packaged it up and given it a proper name or released it yet. So those details will all change.
これは彼が今作ってる途中でとりあえずつけた環境変数の名前なので、今のところある名前ですけど、リリースするときには多分違う名前になって出てくるはずです。で、そのレベルサイズなんとかで使ってないです。
Does the command run the HTTP server? The command you set the environmental. The command that you set as an environmental variable runs the HTTP server or not?
No, there's another bit of software that runs the web server. It's about 2 pages of code.
Okay, thank you.
これをなんか出すやつはまた別に ACP サーバーであるということです。はい。で、とりあえず以上ですね。また何か質問あったら、僕と2人でいるところ見つけて、翻訳するんで聞いてください。はい、ありがとうございました。